All right. So there we go. No, we got nothing. We got nothing on the screen. All right, so 510 degrees, they want us to find, well, all 6 trig functions for 510 degrees. So remember what we were talking about yesterday, right? What you guys thought about all day long, I'm sure, right? Unit circle. So, unit circle, 510 degrees. So the exam we're going to take, when is our exam? Next Wednesday, Thursday. Next Wednesday, Thursday. Part 1 will have all the trig and no calculator at all, right? You can use a 3x5 card, but no calculator at all on the trig part 1 next Wednesday, Thursday, or next Wednesday, I guess. So anyway, so how do we do it? How do we find 510 degrees first off with the unit circle? It's more than a full circle, isn't it? It's more than all the way around. How much more? Yeah, subtract, is it 150? Yeah, 150, huh? So 150, so if you subtract a full circle, it's 150 degrees beyond a full circle. So find where that is on the unit circle. This is 0. This is 180. And then all the way around is 360. So 150 is about right there, isn't it? 150 degrees. It's 30 above the x-axis on the left side like that, huh? So that's where 510, right? Because 510 is 360 plus 150 more, isn't it? Everybody see what we're figuring out there? I located the 510 degree angle by doing a full 360 and then there's 150 more. So it's all the way around 360 and 150 more. So that's where 510 is. It's right there. And okay, so that's good and everything. So how do we figure out like the trig function values at that location? What do we do? Yeah, so it's 30 degrees this way. So it's, remember, it's back a large amount, up a small amount. Back a large amount, up a small amount. Remember the small, medium, large thing, right? I was giving you the way to memorize these. The small, medium, large. So, and what am I talking about? Small, medium, large. What are they? What's the small, medium, and large? Yeah, square root of 1, square root of 2, square root of 3, all of them over 2, huh? Square root of 1, 2, 3, over 2. Square root of 1, 2, 3, over 2. That's what small, medium, and large is. To make it super simple, right? Just square root of 1, square root of 2, square root of 3. Square root of 1, that's really just 1. You don't really need that root, huh? That one's just a half, huh? But it just makes it easy to remember that way. Okay, so, and then for this spot here, back a large amount. You can tell this is pretty far back, and then up just a little bit. Back a small. Remember, if you're in the middle, it's back medium, up medium, and if you're, yeah, you got it. So, back large. Now, what's large? Well, large is this one. So it's back root 3 over 2. Up small, what's small? Up a half. So this one's up a half. So the coordinates of this point are back root 3 over 2, up positive a half. That's the x, y coordinates of that dot of the 150 degree angle dot, which is the same as the 510 degree angle dot, right? Back large, up small. Back root 3 over 2, up a half. And remember, the cosine is x, the sine is y. That's all you got to do to find sines and cosines, is just find the x coordinate is cosine, the y coordinate is sine of any dot on the unit circle. So remember how this works? We memorize 3 spots in every quadrant. We memorize those 3 spots in every quadrant with the small, medium, large stuff. That's how we do it. Any other dots, you just use your calculator. That's basically it. I mean, other than the axis spots. I mean, we can also find the spots right on the axes. But, so we memorize the 4 axis spots and the 3 dots in every quadrant using the small, medium, large. And the rest of the stuff, any other spots, you just use your calculator. And that's exactly what, I won't expect you to have any other spots memorized. But it's still valuable to know these ones by using the memorized information. Okay, so what's the sine? So sine of 510? Yeah, it's positive a half. What would be, the next question is going to be the cosine. Cosine of 510? Negative root 3 over 2, because it's the x coordinate, right? Cosine is x, sine is y. Tangent? Yeah, that's sine over cosine, huh? Sine over cosine. So sine, what was sine's a half? Over cosine, negative root 3 over 2. Remember what you do? Fraction over fraction. You take the one on the bottom, you flip it up. So that would be a half times negative 2 over root 3. These cancel, negative 1 over root 3. Can't leave a root on the bottom. So we get rid of that by multiplying top and bottom by root 3 and get what? Root 3 over regular 3, still negative. Negative root 3 over regular 3. So there's the tangent of 510. So I get the sine, cosine, and tangent of 510 degrees. And then the other three are just upside down of these three, right? So I won't bother wasting any more time on it. Is that good? Questions on that? Getting the hang of how we find these values without a calculator? So again, the method is you memorize 3 of them in every quadrant. Everything else you just use a calculator. That's valuable because you might, if I was you, I would, why don't we just do them all in our calculator? Well, because if you know 3 in a quadrant, you know the direction of something. So when you go into calculus, and they talk about a limit, and then you have like a tangent or something, and the thing's coming down like this, because that's what happens in calculus. You have something headed in a certain direction. And say you have a dot coming down like this, headed to this spot, but it doesn't quite hit that spot. It gets super close to that spot. The way you'll know what the tangent is doing is because you've got some of these values memorized. Or say the sine. Say we're talking about sine. We have some angle coming close here. You go, well, the sine, as it gets really, really close, sine is the height. It's the y-coordinate. What's the y-coordinate doing? It's coming down to 0. You know the direction it's going. That's where it becomes valuable. All right, so let's go too many of these early ones, but I want to get you comfortable with the unit circle. So try that. See if you can find on the unit circle negative 315 degrees. What do you do when the angle's negative? Yeah, go backwards, huh? So we always start here, right? They just by common agreement, they made that 0 degrees. They could have started us at the top or whatever, but they just decided this will be 0 degrees. So go down, go negative 315 degrees.
Isn't that just 45?
Yeah, that's right. Okay, everybody finding that? 315, you end up right here. Right, negative 315 degrees ends up at 45 degrees, doesn't it? How am I getting that? Because just taking 360 minus 315, you get 45. So it's almost all the way around backwards, but it falls 45 short of going all the way around. Right? So it falls at 45 degrees. So it's, in other words, it's exactly the same as if they'd asked you positive 45 degrees. Those are the exact same spot. Everybody making sense out of that? Positive 45 is exactly the same spot as negative 315. They are the same spot. Right? You can say the same spot several different ways, huh? You can always just add another 360, and it just does another full circle, so you're right back to where you started, having done another loop, right? So, yeah, so negative 315 is the same as 45. Okay, so now how do we do the sine, cosine, tangent? Well, you go, where is that one? That one's right smack in the middle, right? Because 90 is straight up. So 45 is right in the middle. That's over and up, both medium, huh? That's not small or large, right? It's right in the middle. So it's the medium, like ordering a soda. It's the middle size. It's medium. So it's over medium, up medium, right? From the center here, over medium, up medium. And remember the numbers. It's root 1, root 2, root 3. All over 2, small, medium, large. So the medium is root 2 over 2. So that means it's over root 2 over 2, up root 2 over 2. The coordinates of this spot are positive root 2 over 2, comma, positive root 2 over 2. And the sine is the y. They're both the same. So the sine of negative 315, positive root 2 over 2. What's the cosine of negative 315? Same thing, because cosine's the x, sine is the y. What's the tangent? Yeah, negative 315. It's going to be sine over cosine, which is root 2 over 2 over root 2 over 2, which is a big fancy positive 1. And the other three, secant, cosecant, and cotan are the reciprocals. They're the upside down, sine, cosine, and tangent. So we can do those easily.
So the tangent would stay 1.
Yep, cotan is going to be just 1, isn't it? Yep. What is cosecant going to be? And secant?
Root 2.
It's going to be root 2. Yeah, because when you flip that over, it ends up, and you simplify it, ends up being root 2. Yeah, those are both root 2. We good? Am I moving too quick? We good? Trick's not hard, right? Just unit circle, find the spots. That's like hit the button. So that won't be on part 1 of your test. Yeah, so this one, secant of 56, let's use our calculator. That's not one of our memorized spots, right? You guys tracking with me? Which ones do we have memorized? Well, just the 3 in every quadrant. Just 30 degrees, 45, and 60 in every quadrant, right? We just memorize those 3 in every quadrant. Any other angles, we just use our calculator. So what's the secant of 56? Well, you might have a secant button, but a lot of calculators don't. So what if you don't have, what if you just have sine, cosine, and tangent?
1 divided by.
Cosine, huh? This is 1 over cosine.
And you have to put it in parentheses or it won't work. Put it in parentheses.
If you have higher vocabulary, you don't have to worry about it.
I don't think any parentheses are needed on this one, really, for any calculator, unless I'm missing something.
No.
So, yes, I think it'll work whatever. So we got an answer that says round to 2 places.
1.17.
Anybody else getting that? 1.17. We good there? That makes sense. 1 over the cosine, so that's the secant. 1.17. So just hit the buttons on your calculator. If you're having trouble, grab it. Yeah, Ray.
I got 1.79.
Oh, so 1.7978 rounds to 79? We good now? Oh yeah, make sure you're in the right mode. There's degree mode, radian mode. Right? Yes, well, watch out for that. Make sure you're in the right mode. You know where the mode button is on your calculator? Hit the mode. Check. We're in degrees right now, right? Make sure you're in the degree mode. So watch out. Make sure you're in the right mode when you're doing these. We good? Is it all good?
Yeah.
So if you have trouble, grab me after. But yeah, always double check. All right, so the cotan of 2 pi over 9. Now, 2 pi over 9, is that degrees or radians? Yeah, it's not degrees. There's not a degree symbol, so it's radians, huh? So, that's going to be 1 over tan, right, if you don't have a cotan button, of 2 pi over 9. So use the pi button. You usually have a pi button on your calculator. Use that. Don't just type in 3.14. Use your pi button. It's more accurate. And let me know what you get. 1.19. Anybody else getting that? Am I right? 1.19. That okay? So they just say use a calculator. We good? 1.19. So I'm going to move forward. Grab me later if you're having trouble with the calculator, or feel free to compare with those around you. 1.1. Okay, so now they're gonna kind of play the game backwards. They're gonna give me the spot on the circle, right here. This is the point on the circle. Over 7 down 2. That's the x and the y. So over 7 down 2, like something like right here. Over 7 down 2. They're telling me that is on the terminal side of the angle. By terminal, they mean this is the initial side. That's where you start, right? All the angles start there. And terminal just means ending, right? So this is the terminal side. This is where the angle ends. So this is the initial side. All the angles start there. And then at 0 degrees. And this is some angle. I don't even know what the angle is. But I just know the terminal side, the ending side, the final side of the angle is right there. Honestly, I don't know if they went down or they went around. Who cares? Either way, they ended up at this dot. One way or the other. Maybe they went around 10 times and ended there. Doesn't matter. All I care is in the end, they ended at over 7 down 2. I don't know exactly where that is. I just know it's somewhere in the lower right. So I just kind of put a dot in the lower right. All I know is it's right and down, right? Positive and negative, right? Right and down. So how am I supposed to find the trig functions there? Like, what's the sign of that angle theta, whatever it may be? Yeah. Now, can't I thought we said cosine is x value, sine is y. It's just -2. Wrong. Which you know. But why? Why is that not right all of a sudden? I thought I said cosine is x and sine is y.
We're not in the unit circle.
We're not in the unit circle. We're not in the one circle anymore. This circle does not have a radius of 1. So that whole thing I was giving you, where cosine is x and sine is y, that's only when you're in the circle of radius 1, the unit, the one circle. So this, let me write that out. This is not the unit or the one circle. So what? So what does that mean? So the sine is not just the y value. The sine is y over, you may know? Radius. It's y over radius. See, normally the radius is 1. So then that's just y when you're in the unit circle. Does that make sense? But if you're in some other circle that they just make up like this one, you got to realize it's y over r. So we got to find the radius. You guys are totally right, the Pythagorean theorem, huh? So the way we find the radius is the Pythagorean. So let's go back and say, okay, so here, let's make a little triangle here. Right? I know it's over 7. This is 7. This is down 2, so I can find the radius. It's a little right triangle, Pythagorean theorem, huh? Is that making sense? Over 7, down 2, as they told me. So 7 squared plus -2 squared is r squared. Right? A squared plus b squared is c squared. So what's that? 49 plus 4 is r squared. 53 is r squared. So r is the root of 53? Whoop, I'm off screen, huh? Put it down here maybe. So r, the radius, is the root of 53. Well, they want an exact answer. Oh, yeah, so we can't leave a root in the bottom, huh? Yeah. So let's go back over here. So we got the sine. Sine is going to be y over r. So now the sine is y over r, so it's -2 over the root 53. But yeah, we can't leave the root in the bottom, so we got to clean that up. Is everybody good to there so far, though? Do you see why this is different than the other examples? Because this is not the unit circle. They made up the circle instead of me making the circle, right? The other ones, they just gave me an angle and I put them on the unit circle myself. This time they gave me coordinates on a circle. So I had to go with their circle, which is not a unit circle. So I had to find the radius. So the sine is really y over r, cosine is x over r, etc., etc. So anyway, you got to get rid of the root 53. Multiply root 53. Top and bottom, what we got? -2 root 53 over plane 53. So there's the sine. Cosine's going to be x over r. So that's going to be the x value 7 over root 53. Can't have a root on the bottom. Oops. Multiply top and bottom by root 53. Get 7 root 53 over plane 53, like that. So that's cosine, got sine, got cosine, and the rest are the same because tangent is still just y over x. You don't need to put the r in there for tangent because it's got both y and x. If you want to be more formal, it's y over r over x over r, and the r's cancel. Boom, boom. So it's just the same thing it always was. Am I going too quick on that? Do you see mathematically why that's true? Right? Maybe I'll be more formal and show it slower. Tangent is y over r over x over r, but if you flip that up, that'll be y over r times what? R over x, and the r's will cancel, and you see how it's still just y over x. So tangent's still just y over x, because the r's cancel. So, that enough for that one? Can I leave it? Does that make sense? So it's not a unit circle, got to find the radius, and sine is y over r, cosine is x over r. Normally, unit circle, radius is 1. So we ignore the r. It's just 1, normally. I think. What is this?
Excuse me, I know.
Yeah.
Really?
Yeah, it's just arithmetic.
Yeah.
No, I don't think so. Because 50 is not a nice place. It's not a memorized value. Right? Yeah, you guys with me? 50 is not one of my memorized locations. And they're saying, where do they say it? Exact value, which means no decimals, no calculator. So the first thought that should hit us is, wait a minute. They're asking me to do a spot, 50 degrees, that's, because what do I memorize? I memorize 30, 45, and 60. I don't memorize 50. That's what I normally use the calculator for. They're asking me to do 50, and that's not one of my memorized, which is okay, I'll pull out the calculator, but then they said exact. I mean, I don't want no calculator. Don't give me no decimal. I want exact. Well, how am I going to do that? So we need some property. So you see how I'm arriving at that conclusion? There's some special, like, sign rule or tricky rule that I must use because the normal thing's not going to work. So everybody seeing that? I can't do the calculator because they want exact. They don't want decimals. And 50 is not a memorized spot. Either is 130. Now, let's start looking for a property. What property? Well, notice. Honestly, even as I talk to you right now, I don't know. I'm hoping it comes to me soon. Otherwise, I'll have to look back at my notes. But here's what I'm noticing: 50 and 130 add to be what? 180. That's nice. There's something special there. That you kind of jump off the page where you're like, 180. I wonder if you can do something with 180. I'm still wondering with you, but I think there is something. Now look at 310. Oh, 310 and 50. What do they make? 360. That's super nice. 310 and 50 make 360. And these make 360. Yeah. Yeah. What does that mean? Zero. Zero. Do you see it? Let me show you. It's all about picturing the unit circle. All right. Here we go. Let me drop more careful for you. Oops, now I'm making a tall A. Art was not my skill. I don't know if you can tell. All right. So 50 degrees. Now, where's 50? Just a little past half. 45 is halfway, right? This is 90. 40, this is 0. So 50 is about little more than halfway, right? Where's 130? Well, it's 90 and 40 more. It's same distance this way, right? Right? That's right there. Now, where's 230? Well, 230 is 180 and 50 more. But right here. 230. And then where's 310? This is 270. So 310 is 40 more this way. 310. Okay. What is my point? The sign. Okay, look at these 4 dots. In all cases, they want me to figure the sign of those dots. What's the sign? Which coordinate? The y coordinate. They want this positive y coordinate. How do you think that compares to this y coordinate? It's the same thing, right? Because this is 50 degrees this way, and this is 50 degrees that way, right? From 360 down to 310. See how they're the same distance up and down? They're going to add up to be eggs. 0. They've got to. I don't know what they are, but I know they're the same. One's positive, one's negative. See how I know that just by looking at the picture? You see that? Right? Positive 50, negative 50. 310 is negative 50. Right? Positive, negative. They're going to be the same thing. They're going to cancel out. They're going to totally cancel out. Aren't they? Everybody see that? That makes sense? Surrey's not sure. Nobody knows what the real answer is. Same thing here, right? Positive y, negative y. It's going to be 0. Like that. Now, there's probably some special rule. You can tell the way I do math, right? I don't have a bunch of rules memorized. I really don't. I just kind of figure stuff out.
The same thing what you're saying right there, there is a special rule for it.
Yeah, what is it, Robert?
It's been so long since I...
Yeah, I'm a little rusty too. I'll look at my notes to get you the special rule, because some people like rules.
But if you look at what you're doing, it's the same. You know how you went to 50 degrees? You add 130 degrees, that takes you to 180, like you said.
Yeah.
And then if you add 230, 230 to it, it takes you to a certain spot. And then 310, it just takes you all the way back around. So that's 2 full revolutions, which takes you to 0.
I'm sorry, what do you say?
If you look at the degrees altogether, it adds up to 720.
Gotcha.
And so that's 2 full revolutions around, which takes you to the sign of 0.
Yeah,
It lands in the point 1, 0, and sign of 1, 0.
And the sign of that point right there is 0.
So you're saying add up all the angles, 720, that's 2 full circles, 0.
I'm just looking at it like you're looking at it, kind of, but you know how you went to 50 degrees?
Yeah,
From 50, I would add 130, which takes me to 180.
right. I hear you. So you're adding up all the angles, getting 722 folders. I don't think that works though.
But it takes you to a point on the unit circle, which is 1, 0.
I hear you. Let me respond.
Right.
Okay, so if that was true, if you could just add up the angles and they end up someplace and that's that, then couldn't I say, okay, take sine of 90,
Right.
right, and take, what's 720? 8 of those. Add that up 8 times.
Okay.
That'd be 720. That ain't 0. Because what's 90? 90 is 1.
Right. Good call.
8 times sine. So you can't use that logic, right? That logic doesn't really fly. Does that make sense? So see how I test logic? That's what you want to learn to do more and more as you do math and science. I don't have a bunch of stuff memorized. I just take a thought and I test it logically, right? I mean, that's what they're trying to do in you mathematically as you move forward. So I just kind of look and go, that won't work.
The question help will show you what they actually do.
That's a good idea. That's a good idea. Yeah, there's some property. I'm trying to think what it is. I just like drawing the picture because I have a bad memory and I don't remember all those little rules. I just like drawing the picture.
It is something weird though.
Yeah. Let's see. So they're saying cotan of theta is 5. They're calling it f of theta. That's just like naming your pet Rover. They're just giving it a name. They could have called it G. They could have called it Rover, whatever. So don't be thrown off by that. They're just saying, hey, f of theta, we're going to call the cotan f of theta. Could have called it G, could have called it anything. And then they're going to throw in a plus pi. So really what they're asking me is what is the cotan of theta plus pi? Remember, cotan of theta was 5. So let me slow down then. So they're giving me some random angle theta. I don't even know what it is. I have no idea what it is. It's just some, and they're saying, hey, there's some angle theta. And when we take the cotangent of it, we get 5. Now, what if you add pi to that? That's what they're saying. See what they're saying there? They're saying take some random spot theta. I don't know, wherever. Boom. Let's say that's theta. We'll just say that's theta. No, I wrote pi. That's theta. Let's say. And the cotangent there comes out to be 5. What's going to happen if we go pi degrees further? Well, here's where you need to know the period of the functions. Tangent and cotan. You remember the period of tan and cotan? So here's where it is good to memorize it. Put them on a 3x5 card. The period of tangent and cotangent is pi. What does that mean, the period? The cycle, how long till they start repeat, right? So that means every pi, the values repeat. It's a cycle. It just keeps repeating all the same values every 180 degrees or pi radians. Remember that from your trig background? Sine, the other 4, sine, cosine, secant, and cosecant, their period, anybody remember? 2 pi. Yeah. So it is good. It will help you in calculus to know that cold. Really, and if I say it, because remember, I have a bad memory and I try to avoid memory all I can. But if I memorize something, it's usually because I've been forced to. It's useful. It comes up a lot. I would encourage you to memorize it for calculus. The period of tangent and cotan is pi. Notice all values in tan and cotan repeat themselves every pi. And for the other 4 trig functions, it's 2 pi, the period. So know the period. So what that means is if you're at any angle and you add pi to it, you're going to be back where you started. So it's going to be 5 again. The answer's 5. I don't even know what angle theta is. But whatever the cotan was there, it's going to be the same when you add pi more. Because it repeats values every pi. Does that make sense? It's 5. It's just 5. What if they had said cotan of theta plus 3 pi? Still going to be 5. Are you tracking with me? Because anytime you add a pi, 5, add another pi, still at 5, add another pi. So, I'm doing 2 pi circles, but whatever. Every time you add a pi, pi is at 180, it's halfway around. Anytime you add a pi, it's going to be 5. It's going to be 5 on that. Does that make sense? We good? All right. Here. So let me show you the notation so you hopefully won't get thrown off. So they're saying f of theta is the sine of theta. So f of 45, they're saying if theta is 45, Well, then that's just, they're just asking for the sine of 45 degrees. Does that make sense what they're doing there? They're saying f of, they're just giving a name. Again, functions are just names, huh? Like naming your dog or something, right? They're just saying sine of theta is f of theta. And they want the f of 45 degrees, so that means the sine of 45 degrees. And what is the sine of 45 degrees? Yeah, we've already, you can do the unit circle, you probably have it memorized now. Yeah, that's the one right in the middle, over medium, up medium, root 2 over 2, root 2 over 2. The sine is the y value, root 2 over 2. And then they want the cosine. They're calling cosine g. Again, they're just giving it a name. And so when they say g of 45, they're saying cosine of 45, which is also root 2 over 2, isn't it? Good on that? So it's just a fancy way to ask us for the sine of 45 and the cosine of 45, huh? By giving function names in there. There's nothing there. Think. All right, so they're saying f of theta squared. And f is sine, so they want, and theta is 60, so they want sine of 60 squared. Does that make sense how I got to there? They're saying f is sine, and they're saying the angle is 60, so they want sine of 60, and they want it squared. So let's find the sine of 60. So 60 is like right there. Yeah, that's the one that's over small, up large. It's over a small amount, up a large amount, huh? To get to 60 degrees. It's over a small, it's over a half, up a large, up root 3 over 2. Over a small, up a large. And the cosine is the x, the sine is the y. So which one is the one sine? Okay, so root 3 over 2 squared. We good there? So what's this root 3 over 2 squared? Yeah, 3/4. That makes sense? We good there? Questions on that? No questions? We all good? All right. The sine and the cosine. All right, so f plus g of 60. So they want me to, so they're saying add f plus g of 60. So that just means the sine of 60 plus the cosine of 60. F is the sine, g is the cosine. So f plus g of 60 is sine of 60 plus cosine of 60. Okay, so how do we figure those out? Excuse me. Excuse me again. Yeah, we just did the 60, didn't we? So we know the value at 60. It is over small, up large. So it's over a half, up root 3 over 2. Over a half, up root 3 over 2. So the cosine is the x, the sine is the y. So the sine of 60 is root 3 over 2. The cosine of 60 is the half. And that's it. There's really not much more we can do with that, huh? I mean, yeah, just leave it. That's fine. Is that good? We happy there? All right. So, So f. What is that? They're going f. What does that little circle thing mean? Composite means, it means, in other words, f of h. So it means plug one function inside the other. Remember that? It's been a while since we've done that. That little circle in the middle is composing the functions together, putting one function inside the other. I think I said put your toaster inside your refrigerator kind of thing, right? One function's inside the other. That's what that little circle means. So they're saying, all right, f of h of 60. Now what's h of 60? What does the h function do? Yeah, it says 60 over 2, which means we're talking f of 30. Everybody track with that? Right? The h function is the cut it in half function, isn't it? So we cut the 60 in half, 30. And now, what's f? The cosine. So when all is said and done, they want the cosine of 30. That makes sense. So we draw our little unit circle. We go to 30 degrees. Over a large amount, up a small amount, over root 3 over 2, up a half. Over root 3 over 2, up a half. Cosine is the x, sine is the y. They want cosine, root 3 over 2. Good? All right, that's 20. Okay, so part A, f of pi over 6. So the f is the cosine function. So they're really just saying, find the cosine pi over 6. Yeah, what is pi? How do you turn pi over 6 radians into degrees? Yeah, because remember what pi is? Pi is always 180. Just stick a 180 in for sine. 180 over 6, 30. It's cosine. We just did cosine 30, didn't we? All right, we just did the unit circle. Cosine of 30. Over large amount, up a small. Over root 3 over 2, up a half. So the cosine is the x, like we just did, root 3 over 2. So that's part A. Now part B, that was all part A. Part B is saying, use the results of part A. What point is on the graph of f inverse? Oh wait, no, I didn't quite finish A. A said what point? They don't just want the answer.
Pi over 6.
Yeah. That's kind of confusing. The answer to part A is, let me see, how do I explain it? For part A, they want an x and a y. Yeah, let me just show it that way. See how in part A they're saying what point? This is kind of weird the way they're asking this. This could mess you up. Let me show you what they're talking about. Before we get on to part B, we're not really ready for part B right now. So part A, they want a point, which means they want an x and a y, right? Now, you might be tempted to come over here and say, well, it's just, it's just over root 3 over 2, up a half. Not quite. That's where it's a little confusing. That's the xy point on the unit circle, which is different than the xy point for the function. Remember, y values are f values, aren't they? So, and what is the x value? It's what you plug in. So the x is pi over 6, right? That's what we plugged into the function. That's always, when you plug into a function, that's your x. What you're plugging in, and what you get out is your y, huh? That's how functions work. They're making sure you're really clear. I didn't realize they mixed functions in so much here. They're making sure your thinking is really clear on what functions are and do, how they work. Again, you plug into a function x, what you get out is y, right? Whenever you work with a function. So with a function, input is x, output is y. So when they say they want a point, which means x, y, they want, what do I plug in? Pi over 6, and what comes out, that's the root 3 over 2. Even though on the unit circle, the root 3 over 2 is actually the x value on the unit circle. But for this little function they made up, root 3 over 2 is what comes out, right? What goes in, what comes out. X, y. Make sense on that? For part A, that's a little tricky. All right, and then part B. So this is a point on the original function f. Part B says, give me a point on f inverse. Swap them. Exactly. Remember inverse functions, just switch x and y? That's all they do. So you just go, okay, root 3 over 2, comma pi over 6. They're just making sure you remember. They're tying old stuff together with the new stuff here. Remember inverse functions? Just switch x and y. Remember that? Okay, so that's part B. And then part C, what point is on the graph of all that? If x is pi over 6, I don't know. Guess we got to figure all that out. So, so I guess we just plug in pi over 6 there and just kind of figure it out. So let's see. So f of x plus pi over 3 minus 2. And they're saying let x be pi over 6. So I come up here and I put in the x slot, pi over 6. Good so far? So I've just taken that function and plugged in pi over 6 for x. And so this is f of, now what do I do there? This is, what do I got to do with the inside to combine these? Common denominator, huh? Everybody good with that? I got to multiply by 2, top and bottom, like that. And then I get, what's that, 2 pi over 6? So that's f of 3 pi over 6, which is f of pi over 2. Good to there so far? This is all part C up here. So I'm down to, I plugged in, you know, for the x, the pi over 6. Simplified it. So it's f of pi over 2. Can I erase some of this now? So f of pi over 2. Now, what's pi over 2? Yeah, because pi, remember, is 180. So I'll put in 180 for pi, so it's f of 90. All right, we've come to this point. F of 90, so it's right there. It's at 90 degrees. What's the coordinates of the dot that's at 90 degrees? Over 0, up 1, huh? And cosine is the x, sine is the y. So, what do they want? What is f? Is it? Oh yeah, right up there, huh? Yeah, f is cosine, huh? F is cosine. So this is really cosine of 90 minus 2. And what's the cosine of 90? 0. 0 minus 2, negative 2. That was a lot of steps. The answer is negative 2. Are we good with that? That makes sense?
It wants the point.
Oh, does it want the point? Well, they just keep bugging me with this point thing, huh? Yeah, so they want the point. So that means they want the x comma y, which means they want what you plugged in. What did I plug in? Pi over 6, right? X is pi over 6. And then the answer you got out, negative 2. So they actually want pi over 6 comma negative 2, yeah. Thanks, Kelton, that's right. Good. That was a long one. I thought we were